So good afternoon, Mr. Chairman and everyone, and thanks for joining my today presentation. So my name is Hassan Bardareh, and I'm an R&D specialist at Moselhi Construction Group. So this today topic is the last piece of my PhD work, a proof of concept on a framework for automated generation of the inspection report of the construction operation. So here is the agenda for today. After introduction, we have a development code. We talk about the experimental study we did, and finally we have the summary and remarks. So first, let's see what is the monitoring, progress monitoring means in construction phase for us. So for us, everything starts with the plan data of the project. So we catch the information about the item we want to track. So after that, what we can do, if we can see how the activity should be done, and what activity and at what time. So this way we can decide in what sequence, in what workflow we can collect the information, hopefully automatically, but sometimes we need to do it manually. So all this information I gathered as an as-built information of the project. By comparing to as plan, we can make some assessment about the progress of the project. So this progress monitoring cycle has some benefits. It can help us to improve the invisibilities of the projects by bringing and tracking of the operations. Also, it can help us by using the technologies to automate the whole process and have less manual things to do. And it has a lot of opportunities for integration of the IoT, computer vision, AI, and in a more systematic way. So in this PhD study, we narrow it down, this topic, to an indoor object localization that we will talk about why. So about the indoor, compared to outdoor, we have some challenges. Indoor is more complex. We have obstacles. We need more infrastructures. So technologies like GPS, that is very good for outdoors, for indoor is not working. We have to rely on technologies like RFIDs, QR code, ultra-wideband, BLE, ZigBee, and there's a long list of these technologies. So, and what we mean by location identification of the objects and, let's say, building components, we refer to three pieces of information. We need to have the ID we assign to an object, could be anything like a building component, the coordinates XYZ, and the status we give that we can track the projects. So about the ID that we give, there are two types of ID we refer to in this study. Is a physical ID that you attach to some components on the real job site, and there is a digital ID that you have it back end in your database or in the like a BIM map. So about the overview of this method and how it works, is an integration of the IoT technologies and the laser scanner and point cloud data. So the IoT includes an integrated system of the RFID and ultra-wideband that can localize everything in indoor spaces. So the laser scanner can help us to have accurate 3D localization versus the 2D localization that the RFID provides for us. The processing includes two things: the trilateration technique for the tagging technologies and the computer vision techniques that we will talk about two of them. The PointNet, which is developed by Stanford, that we tested, and then we use a ready-to-use platform called Mercato for the object detection and localization. And finally, the reporting part includes three pieces of reports. The progress reports that tell us about the quantities of the installation has been done. The coordinates deviation is another piece of report that tells us how accurate and how well the installation has been installed. And finally, we have something called the quality QSI index that we tell us what was the quality of the material used for the installation. So here is the step-by-step how the whole integration works. So we start from the RFID ultra-wideband technologies and the tags attached to building components. So we have a 2D and 3D localization with a range of around 3 meter accuracy. To improve the localization part in 3D fashion, we use the point cloud data and computer vision who help us to catch the accuracy of range of decimeters. So the integration includes exchange of information between these two systems, and finally to catch the XYZ coordinates of the components in the installed locations. And finally, we have the reporting in the tree base for the prices, the quantities, the status, and for the quality of materials as it is. So to validate this study, we did experimental work in the automation lab of Concordia University. So we use a benchmark of like 10 chairs on the ground that we tag them with some QR code RFID tags in the 10 tie points. And we use a laser scanner for 3D scanning. And we put some configuration for the scanner in the quarter for resolution and for X for the quality. And each scan took us around 12 minutes. And here is like the schema of the experiment we did. You see the chairs distributed in the lab. We have some obstacles as a wall between, and the data are collected. So the whole story, like I said, is the exchange of the information between the tagging and the laser scanner point cloud data. That the tagging gives us the ID and approximate XYZ locations. So by exchanging the information, the data with the point cloud data, they can have more accurate XYZ locations. And this goes on until we achieve ID, time, and the accurate 3D location of the object. So to validate the computer vision techniques, we use like a platform called PointNet, a network called PointNet for the test in the experimental test. For training, we just use a Stanford data set, so we can see the result. So there is another platform in market called Mercator Cloud, which use the point-based algorithms for the object detection and use the semantic segmentations. So you see that we have achieved a detection rate of around 70%, and we have the accuracy around 27 centimeters for localization. So for summary, so what we talk about, we talk how the reports can be generated by using the IoT and computer visions. The further studies is needed for integration of these two data, how we can manage, what segments we should do to do this integration. The second, the computer vision need to be tested in the real job site for MEPs mostly. And finally, the 3D localization algorithms and computer visions need further studies to enhance the object detection capabilities. Yeah, thank you so much for your attention.